David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you could turn on the captions and follow along with my words on the bottom of your screen. Today's lesson covers modeling with trigonometric functions. Whenever you see the word modeling, you know we're using mathematics to describe some situation in reality. Observable data, match it to an equation, things like that. So let's take a look at an example here. So what we have is a graph of the depth of water at a certain harbor. So this fluctuates over time with this curve, which, as you might guess, looks pretty much like a trigonometric function, and indeed it is. And so what this is showing us the depth of water in meters over time in hours after midnight. So that's midnight. This would be 2 a.m., 4 a.m., 6 a.m., 8 a.m., and so on. And you can see the water is rising, dropping, rising, dropping. So this graph is basically a bunch of data. And what we're going to do here is we're going to write a trigonometric equation that describes this data. All right, so let's get started. We need to find our A, B, C, and D, and also decide on what function to use. So first off, find the amplitude. So take a look at this graph and think about it and see if you can come up with the amplitude. All right, so I want to give you a little equation that helps you find amplitude. It's always going to be the max minus the min divided by 2. You can also analyze the amplitude by just looking at the graph, but from working with several of you in the classroom, I know that's sometimes challenging. So what you can do is a more plug-and-play approach is just figure out the maximum, which would be 8, minus the minimum, which is 2 off of our graph, over 2. So that's 6 over 2, or 3. So our amplitude for this function is 3. All right, so now let's find the b term. What is my b? Pause the video and see if you can figure that out. All right, b is a little bit tricky. You have to remember this little equation that we've used a bunch of times. The period is 2 pi over the b term. So we're trying to find what b is for our equation. So we have to go to the graph and see what the period is. Now I think the easiest way is to go from that peak to that peak. That's a full cycle of our function, a full period. So this peak is at 4, that peak's at 16. So 16 minus 4, our period is 12. So we have 12 equals 2 pi over b. So this is the equation that relates b to the period, and of course 2 pi. And so I rearrange and solve for b, I get b equals pi over 6. All right, now we need to decide which function we want to use. It's going to be sine or cosine. And the truth is, you can use either one. This wave is identical, it just gets shifted horizontally. So before we figure out the horizontal shift to use for our function, we have to decide whether we want to use sine or cosine. So in this case, we're being directed to use cosine and find the horizontal shift. Now note, I did put the results from our last 2 calculations up here. We're going to keep racking that up so that we can then write the equation. So pause the video and see if you can figure out what the horizontal shift is. Okay, let's see how you did. Cosine, the basic cosine function, always starts at the max and drops down. Now, our max is shifted 4 to the right. It's 4 positive. So the max is here. So we've shifted the function 4 to the right. Okay? So our c term is 4. Okay. Now find the vertical shift. See if you can do that. Okay, so there's 2 ways to do this. You can stare at the graph and figure it out. And basically the way I know that is that between 8 and 2, that's my max and my min. So my principal axis is going to be halfway between those 2, and that's the line at which the function is equally above and equally below. The principal axis is also the vertical shift. So my max is 8, my min is 2, so halfway between there is 5, so my vertical shift is plus 5. Now there's another more formulaic way to get that, just like finding amplitude, and that's just max plus min over 2. So this is going to be 8 plus 2 over 2, and you can see right now that that also gives us our 5. Okay, now we're at that cool step. What I want you to do is pause the video and write the equation for this graph. Okay, if you needed a hint to get that, here's your hint. Here is the general form for the cosine function with all my a, b's, and c's plugged in their spots. So go ahead and use that and write the equation for that function. Okay, here we go. 3 cosine pi over 6 times x minus 4 plus 5. Straightforward plug-in. But now we have a function that we can plug into the calculator and see this graph. In fact, if you want to do that right now just to see what that looks like, go ahead and do that. All right, now here's a question. Since we have the function, we can answer this question. What is the depth of water at 9:30 a.m.? Now, you could jump on the graph and go, well, there's 8, that's 10, 9 is here, 9:30 is there, and you could try to trace along the graph and just read the depth, but it's not going to be super accurate. But we have a mathematical function we can plug in. So pause the video and go ahead and use your function and this time and find that depth. All right, so here's my plug-in step. One subtlety that you need to track. 9:30, remember, clock time is not decimal. Clock time is base 60. There's 60 minutes in an hour. So you have to recognize that 9:30 is 9.5 hours when you do your subtraction. So I go ahead and did my plug-in step. I did the math on the calculator, and I get 2.1 meters. So it's almost right at the minimum. Remember, the minimum is 2. So at 9:30, it's just beginning to come up. The tide is coming up. All right, last question. There's a boat, and it needs the depth to be at least 4 meters to sail. So we noticed that the tide definitely gets below 4 meters, so the boat can't go out then. It needs at least 4. So the question is, what is the next time after 10 a.m.? So maybe this boat captain's just not to be bothered to get out early. They want to go out after 10 a.m. So the question here is, what is the next time after 10 a.m. that actually works for this boat to go out of this harbor? So pause the video and think about that for a minute. So I'm going to take a look at this graphically. Check this out. I just drew my horizontal line for 4-meter depth, and it intersects our curve in a bunch of different places. And that makes sense. The tide regularly goes above, the water depth regularly goes above 4 meters, dips below, up and below, and in this periodic pattern. So here's our first 2 times in our range of times from midnight forward, but these times don't satisfy that requirement that they be after 10 a.m. So this time is the first time that works for that. Now, what I'd like you to do is put these 2 equations, this one and then y equals 4, into your graphing display calculator and use your trace function or your intersection function to find out what that value is, what the hours are for that one. All right, so when I get my intersection point right there from my calculator, I get 12.35 and 4. So this one is representative of the time, but we're not quite there because it says, what is the next time? This is decimal time, 12.35 hours. When we talk about time, we want minutes. So 12.35 is actually 12:21 p.m. So a full points answer would actually have to go all the way to that. Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.